everyone to today's webinar. Today we'll be addressing simulation and simulation modeling. And our host today will be Denis Gagné. And Denis is the head of Trisatech for more than 10 years now. Denis has been involved in helping create a majority of international BPM standards. He's a member of the Workflow Committee Coalition of WFMC and their steering committee. He's the chair of the Business Process Simulation Working Group, and that the acronym for that is BPSWG. He's also the co-editor of the XPDL 2.2 process definition standard. In addition to that, Denis is a member of the Object Management Group, OMG, where he chairs the BPMN International Working Group, and he's a member of the BPMN and Case Management Modeling Notation, and also those teams, and also the Decision Modeling and Notation team for OMG. He's one of the founders of the Business Process Incubator, and I would suggest it's a great site. It's a great resource for people. If you haven't gone out and checked it out, please go out and check out the incubator. And it's a free online resource providing access to BPM, change management, process improvement professionals, and for different resources that will support those professions. And as I mentioned today, Denis heads Trisatech, which is a global leader in digital enterprise solutions, offering innovative and easy-to-use tools for the entire BPM process. So at this point, I'd like to welcome Denis and turn the discussion over to him.
Okay, thank you very much, Dan. Good day, everyone, and welcome to our webinar on business process simulation. So today I'd like to talk to you about business process simulation and offer you a quick introduction to the BPSim standard, which stands for Business Process Simulation. The BPSim standard is a standard published by the WFMC, which I was chairing the group. I'm still chair of that group at the WFMC. So let me start with a quote, an introduction quote by George Box, which basically George said, all models are wrong, but some are useful. And why do I start with this quote? Is because I think this quote is very important in the context of simulation, and we'll see how this goes along with process simulation in particular. So let's start by looking at what are models. So what are actual models? So models are any structured knowledge that accurately reflects or help us make sense of the real world. So there's two sides to these models. There's the mental model that we have in our mind that try to understand the real world, and then there's the model, the artifact models, cognitive models that are artifacts that we work with. And we usually use these models to make prediction on the world as to what the future state of the world will be, and we use those also to confirm back the model to make sure that we have a model. There are different types of artifact model, so some of those models can be stories, graph, diagrams, equation, computer simulation. There's all kinds of models that help us make sense of the real world and think about the world and manipulate this world. But all these kinds of models all share some specific attributes or properties that we want. So the first one is salience. So models should be, because model cannot represent everything, that's around in the world, models should represent very selectively what we want to represent of the world that we need to for our purpose. Another desired property is accuracy. So we want our model to be accurate with the real world, giving us the actual state of affair and not some erroneous or biased view of the world. The model should be complete in the context of what we want. So we want the model to capture all relevant dimension without squeezing out some of the features that we're trying to explore or experiment with. Models should be simple, so they should be understandable, easy to perceive and manipulate, so we can understand what's going on and make our own interpretation of the results. Now, Mayer's law basically say that it's very easy to make things complex, but very complex to make things simple. So creating a simple, salient, complete model is something that is complex to do. A model should be also coherent, because models don't exist in isolation. They exist into an interlocking system of other models, and we need to make sure that they are coherent with all the external facets of the model. Models should be flexible in the sense that we will want to change the model, we will want to maybe change our scope, look at different facets or different perspectives, so we would like to have these models very flexible. And finally, and most ultimately, models should be useful. So if I go back to George Box's quote that says, you know, all models are wrong, some models are useful, this is basically the goal that we have when we're creating these models, is to create a useful model. And a useful model is useful within a particular purpose of investigation and within a particular context. So I'm providing you with this little introduction before we get into details of simulation, because this is very apropos, and we'll talk more about how this notion of the model affects simulation in general, and we'll talk also on how these are tackled very particularly within a process simulation environment. So the general modeling recommendation here is that we should always model with a purpose. So the idea is to have the right model for the right goal. So there is no such thing as only one model that serves all goals. We have particular models that are useful for particular goals. And then we say the right answer to the right question. That is that we should know what the purpose and the interrogation that we're going to have about this model ahead of time, so we can provide and use the right model to provide us with the right answers to these questions. Now, beyond that, it's important, or it's certainly very useful, to make use of standards, because these standards will ensure universality of your model, will also ensure portability, so that this model can be reused, moved from tool to tools, and also ensure perennity, that is, that these models can, you know, live to be useful for a long time within your organization. So let's switch a little bit to business process management very quickly. So here's what I would suggest is the marketing poster of BPM for the last few years. So in business process management, we're looking for business efficiency. So doing things right, so doing more with less, that we hear often from management and higher level of executive. So it's this notion of attaining this efficiency within the business. We're also doing business process management to achieve business agility, giving us the adaptability in the changing condition of the business that's surrounding us. And also we're looking for business insight into the current status of what's going on, how things get done, and the different outcomes and compliance that the business has to respect. Now, in business process management, we'd like to treat business process model as assets. So here, a little bit of what I was talking about earlier in the intro, we're not only looking at models that are a reflection of the system, but with business process management, we also look at process model to actually be the system. So with standards like BPMN, we can create a model that not only reflects what we want in terms of structure and behavior, we can create a model that is actually the embodiment of the system that's running. So BPMN can be used to actually execute as per the model. So we're taking a layer even more further to what we would expect normally of modeling in the scientific sense by making that the model is the system in this case. So now we want to use these process model as assets in the organization, because not only are they just a reflection, but they are actually the embodiment of the system that they represent. So that provides us with unambiguous description and basically something that is understood by everyone. So now when we're looking at business process, in particular, poor performing processes may lead to all kinds of undesirable situations like delays, backlog, angry customers, loss of goodwills, which is mission critical, and even all the way down to, or all the way up, I should say, to loss of life. In life critical system, you can imagine a system that's controlling environments where humans are involved, and if the system fails, it could lead to some incidents that could be dangerous for the life of the people around us. So we want to use these process model and gain some insight by doing thorough analysis of the business process in a safe and isolated environment prior to deploying them. So we're looking for this risk-free zone where we can do this experiment and all the experimentation that we need to without risking the people or the environment or the resource or the different capital that are involved in there. So the risk-free zone is between this mental and artifact model that we have, where we can manipulate these without having any negative impact on the real world, whether the current real world or the future real world that we're looking at. Some of the benefits of using simulation for this kind of experimentation is that we have a lower cost of transformation exploration, so we can explore many different scenarios at a very low cost. The speed of validation of these scenarios, so we can experiment with these model in hyper speed, so rather than seeing what the impact will be in 6 days and wait 6 days, with simulation we can accelerate this and run the 6-day simulation in just a few milliseconds, plus no disturbance to the current operation. So those are all benefits of doing all this experimentation within simulation rather than in the real world. So simulation for process analysis can be used to do many different things. Certainly provides us some a priori insight. It can be effective for alternative evaluation, decision support when we have to make certain technical or strategic decision, for performance prediction, knowing how a particular system or particular systems of process will perform, and for optimization, looking at getting the best potential throughput, for example, of a particular process. Sorry. So there's different way of dealing with simulation within business process. I'm naming at least 3 here. One of them is the notion of visual depiction. So we have the notion of visualization of the process and animation. So we usually in those situations, the user is presented with, most of the time, an interactive animated depiction of the business process model that the user can interact with and get a sense of the behavior of the process. Another type of simulation is numerical type simulation. Often in process simulation, we'll use discrete event-based simulation, and those are usually used to take values from different users as inputs and use that to simulate how the process model will react given those particular inputs. And finally, another type of simulation of interest within the business process world is the notion of serious gaming or role-playing, where we ask the user to actually play the role of an employee or a specific role within the process and interact with the system as they would in the normal delivered system. So these are what I suggest 3 different ways of thinking of process simulation. Now, when we're doing process analysis, and more specifically when we're doing process analysis with a numerical approach, we're interested in at least 2 types of analysis. The first one is the structural analysis. So we're looking at the structural aspect or the configuration of the process model. And we can use statistical analysis using different static methods to look at structural impact, things like deadlock and all kinds of different things that can be analyzed out of the structure of the process. And we also want to do capacity analysis. And in capacity analysis, we're looking at the capacity of the process. Now, this can be dynamic type of analysis, and we'll use normally discrete simulation methods for this, in terms of looking at throughput, resource consumption, and anything that has to do with the capacity of that particular process model that we have on hand. So when is numerical simulation most appropriate? Certainly within capacity analysis, and mostly when capacity analysis of process that are highly variable. So if you have a process that the outcomes change and it's not really possible to predict just by your mental model. Complex structure or complex behavior, when your process has, a lot of series of decision points and branching and different options and alternative path. When we want to meet some specific capacity constraints, so we have some hard resource constraint, we can use them as independent variable there. So we want to make sure that we remain within our own resources. For example, we may only have 2 of a specific machine type, and we want to make sure that we create a model that live within the boundary of that particular constraint. And when there is interdependent process model, so when your process model affects other process model, and one change in one model affects the other. So these are all signs or indicator for which numerical simulation is very appropriate. On the other end, we'd like to look at when do we think that numerical simulation is less or even not appropriate at all. And these are situations when an expedited analysis indicates that it's a negligible problem. So when we have a certain problem with our business process, it doesn't necessarily mean that we need to use simulation to do the analysis. Some of these problems can be analyzed just in our own mental model and manipulate this to solution or by other methods. There's also when there is very, very little variability or uncertainty in the process model. So if your process model is just a skew of activity that is linear, it's probably faster for you to do this evaluation in a very simple model, and you don't need to do a deep numerical analysis of this. Or when the consequence of poor estimates are acceptable. If you have a situation where the variability of your process model doesn't really affect the bottom line or the other aspects that are important to you, then it may not be worth the expense of investing into different numerical analysis of that particular model. Or when the cost of intervention is less than the cost of the analysis experiment. So if doing your change or your modification or your correction is cheaper than actually simulating this whole process, then you should consider maybe experimenting directly with the system in those situations. Other use of process simulation other than numerical analysis, process simulation can also be used for training and learning. It is very important to use simulation in those cases as well, because we can provide a realistic environment for bringing on board new employees. It could be for persuasion or selling, so you can see the cause and effect through simulation and there convince people of various alternatives and their benefits. It could be for verification and validation, where validation is the idea of, are we doing the right things, or verification, are we doing it right? So we want to make sure that these are the right things that we're doing within this process model. So these are all different usage of process simulation that we can bring on board as tools. So I want to introduce a few best practice regarding process improvement project. The first one is defining success. This is very important and often lost in process modeling, and certainly lost in process simulation analysis. So it's very important to define success so that you know where you're going. So, and know why you're conducting this simulation investigation, and what objectives are you looking for. This will help define the scope, the tooling, and the model that you need to do your simulation. Stakeholder analysis is another very important aspect to it, because when it comes to assessing success in the end, while our own opinion are very important, they're interesting, but in the end irrelevant, because it's the stakeholder that will decide whether you brought value to their problem. So you have to see how your stakeholder defines success, and while it's obvious for maybe your champion or your leader or your sponsor to understand what their objective is, it's rarely sufficient. We have to look at all the other stakeholders and make sure that we have a global success by looking at all the stakeholders involved in this particular project or in this particular simulation investigation that you're embarking on. So in process improvement using simulation, getting the goal right is very important. You have to define your goal and the investigation around, clearly state your objectives so that everybody can agree with it and you have consensus. You also have to match the expertise to the desired experimentation, and we'll talk a little bit more about that later, about the different level of investigation complexity and the different expertise that are required depending on the level of investigation that you're trying to carry out. And another very important point, as we talked before, is to get the model right. Simulation is probably the best example of garbage in, garbage out. A bad model in simulation will lead to very erroneous conclusion. So you want to make sure that you get your model right in terms of granularity and in terms of model parameterization. So clearly defining the goal. Some example of intentions for a goal of a simulation experimentation could be to reduce headcounts or expense, increase the throughput, ensure a certain service level agreement. So those are all good potential goal for simulation experimentation. In designing your experiment, you have to make sure that you understand the difference between your independent and your dependent variables. So the same model under different parameterization can behave very differently. So different process model under the same parameterization. So you have to control which are your independent and dependent variables here so that you have a replication of the model that you really want to simulate. We need to run a series of different settings. This experiment should provide insight in line with your goal. So if you're looking at increasing throughput, you should provide a lot of time in your model on the temporal perspective, and we'll talk a little bit more about that. And then your experiment, you should make sure that your experiment correctly informed the decision. So the conclusion or the decision you're trying to make about this process model. First level of model, getting the model right, is picking the right granularity. Picking the right level of abstraction is very important in a business process model. So it is the idea of what is an atomic task. So for certain problem, I can solve them at a higher level of abstraction. So maybe all I need to know is these 4 or 5 activities and how they complete the process. Where in other situations where we want to diagnose or experiment on actual sequence of activities at lower level of details, then we may want to model our process model with a lot more granularity. So this notion of what is atomic task, that is, what is the lowest level of abstraction we want to go down into our model, is very important. It is important in general in process modeling, and it becomes very crucial in process simulation again, because it guides the level of details that you can get from your simulation. In terms of input parameterization, it is very important how you parameterize a process model for simulation. And I say very important, again, bringing back the garbage in, garbage out. For example, in the parameterizing your arrival patterns, providing a erroneous arrival pattern or providing something that doesn't reflect the reality may lead you to the wrong conclusion. There's also the fact that when you start introducing randomness, you will need to run many replications. A replication is basically running the same simulation many different times with different random variables, so you get a broader spectrum of results, so you can assure that you achieve what you want. And this is the notion of repeated tongue coin. So we all know that when we toss a coin, it's 50-50 chance between head and tail. But if I only toss it twice, I may get head twice, and therefore that may not reflect what I want. So replication in simulation is very important to look. Another aspect very important to look in process simulation is what we call the warm-up period and whether it's required. Warm-up periods are used to reflect the notion of work in progress. So for example, in certain simulation, we may want to run the simulation for a while without collecting the results so that we can create this fully loaded work in progress simulation so that we don't get erroneous environment. On the other end, other process simulation don't require the notion of a warm-up. Give the example here of a bank. A bank every day start without anybody in a queue. So if you're trying to evaluate the queue of people to be served at an automated teller or teller counter, the bank starts with no client every morning. So there's no need for a work in progress or a warm-up period of that simulation if that's what you're doing the analysis on. On the other end, if you're doing an analysis of transactions that are occurring 24 hours a day within the bank, and you're trying to look at the throughput of these transactions, then you will probably want to have a warm-up period to reflect the work in progress that is already in place whenever you start your analysis. Selecting the candidate probability is very important, again, as it controls how correct your model is. It's usually normally based on external observed behavior. It can be either constant or random. Selecting a distribution becomes critical in making sure that we capture the characteristic of, for example, an arrival pattern. So we know that some distribution are better fit to specific situation. For example, a Poisson distribution is better for mutually independent arrival type of patterns. And as you're looking at you're observing the behavior to parameterize your simulation, you have to be careful in looking your historical data that you're not being biased by what's in there. So for example, here I'm giving the example that we have a minimum task time of 8 minutes and a mode of 32 minutes with a maximum of 9.5 hours. These numbers should be a red flag when you're looking at your data and say, well, there is something going on there, and you may not notice that, you know, your maximum time really includes a lot of time when there was a shift off of 8 hours during the night, and you may have missed that. So you have to make sure that when you look or you start from historical data to specify the characteristic of your arrival patterns or any other behavior that you're trying to model, that you may have to do some data cleansing into that data log to make sure that it reflects the reality that you want to capture. It's also important to assess the fidelity on how well your model reflects the current situation. So you want to make sure when you create a process model and you want to do simulation, you want to run this simulation on the as-is situation and make sure that it reflects with high precision as much as possible the current situation, because any change you will do to this model and any modification you will do will be a takeoff from that baseline that you create on the as-is model. So it's important also to carry out sensitivity tests to determine how sensitive your model is to different input parameter. That means that if you start changing the range of some of your distribution to see what the effects are on your model so that you understand how sensitive this model is, because if you just change, for example, maybe just changing your mean value of your distribution by a minor detail, maybe change completely the behavior of your outcomes of the simulation, then you want to be aware of the sensitivity of that particular element in your process simulation. So simulation is often a process of discovery. So we have to examine the output results, and sometimes unexpected results are not necessarily a problem in simulation. Simulation is experimentation. So when we don't get the results that we were expecting from simulation, they are just basically a reflection of the reason why we're doing simulation is to try to find an explanation of how and why we're getting those unexpected results. And they may provide some enlightenment about the actual behavior or some assumed behavior of the process that we were incorrect in our mind. The problem are really when you get unexplainable results, or when you get results that you cannot explain, that's when you really have a problem with your simulation model. Further to analysis, a lot of people use simulation for forecasting and optimization, and the point is that forecasting and optimization is a very complex task. The joke goes here, we can't get it wrong every time, but it is possible with these things. So when we're doing optimization, optimization is the notion of selecting the best scenario or the best solution with regard to some specific criteria. Doing optimization is almost impossible without tool to do that. So you really need good tool support to do optimization. And you also have to be very mindful of the notion of sub-optimization. And sub-optimization is when we find a solution that seems to be the best solution, but we're out of the global context. So think of optimization as a blind person with a cane trying to climb up a hill. So as he's going forward with his cane, up until a point where he sees his cane is giving him the feeling that he's going down. So then he says, okay, I found the top of the mountain. But that can be a local mountaintop and not the actual desired mountaintop, as the little graphic there shows. So in doing optimization, always be mindful of sub-optimization work that you're doing. Now, in picking the right expertise for the right type of experimentation, I've created this little chart there to help you guide you. Given that we're talking about process simulation, and more particularly process simulation using process model like BPMN, I've put this chart here and said, well, if you're a novice in process modeling and you're a novice in simulation, then you're bound to be in experimentation that are learning by experimentation. So you're going to be basically doing a lot of blind testing in there. If you're an expert in process modeling but new to process simulation, then you'll probably want to use simulation to verify the process structure and logic. It's more about making sure that your process model behaves as you expected or as you thought you had modeled it. On the other axe, if you're just starting in process modeling, but you're a simulation expert, then you can hope to do quantitative type of experiment and analysis because your process becomes an abstraction and you can do more experiment. But if your goal is to do optimization, if you're looking for the best possible answer within a set of possible solution, which is optimization, you have to make sure that you're an expert or you have a certain level of expertise in both process modeling and simulation. So that was my intro point about process simulation in general to give you a sense. Now I'd like to jump a little bit and talk to you about the Business Process Simulation Working Group, which is a group of the WFMC that produced the BPSim standard. And you can find out more about BPSim at www.bpsim.org. So BPSim is a standardized specification, so it's a unique common meta model that we call for process simulation. It also provides a standardized interchange format, so we have a unique common serialization or file format, so we can interchange BPSim files. And it's also for process analysis data. It helps support design time parameters as well as execution time results, so getting using historical data for your process analysis. So why did we need BPSim? BPSim was there to encourage and support a wider adoption of simulation within the BPM community. Process simulation is certainly a very valuable technique for supporting process design and improve efficiency. It provides a framework for different scenarios and firm foundation for implementation, and also provide us with an open interchange of these scenarios between different tools that exist in the market. So potential business value of BPSim for process design and validation, for reducing the risk of change, to predicting your business process performance in terms of KPIs or service level agreements, KPIs being key process indicator or key performance indicators, decision support, resource allocation and management. These are all potential business value you can get from using BPSim. So some of the basic tenets on which BPSim was built on, basically not reinvent the wheel. So we made sure that BPSim was a simulation standard that was building up on top of existing process definition language, in particular here XPDL and BPMN as two process definition language. Separation of concern, we'll talk a little bit more about that, about multiple perspective. Reductionist, so we take an approach of divide and conquer. Human consumable, so we have a structured serialization as opposed to a very complex file format. Validation over with running code, so we were doing sandboxing from the first day. And success measure in adoption, we already have very many different implementation, and we even had implementation prior to the official release of the standard. So this is the BPSim conceptual model. Let me talk you through this a little bit. So on the left here in the blue box, we have what's within the realm of BPMN and XPDL. So we have the standard BPMN or XPDL, and when you do a process model, you create an instance of that standard. So you're creating one version of a model of that language or standard. When you're using BPSim, you're basically doing different input scenarios to provide output scenarios that are based on this process model and reference to the process analysis framework of BPSim. So basically, any BPSim file is really an extension of existing file format like XPDL or BPMN. So you can have a BPMN file that is augmented with BPSim information for simulation, and it's still a valid BPMN file. And the same is true about XPDL. So you can transport within these files the input scenarios and also the output scenarios. So a BPSim file can carry both the parameterization and the results obtained. And it's meant to be human consumable, so available for human consumption and be read by people, although it takes a certain knowledge of XML to be able to read those kind of files. So let me start with a little example. So I have here a little process model. It's not meant to be very representative of anything big, but I wanted to show you the difference about different notions. So for example, let me move into an animation context. So let me. So here's what I meant by process animation to validate the behavior of your process. So here in BPMN, we have this notion of a token, and I'm walking through this process, and as I get to this gateway here, I have an exclusive gateway, so only one of the two answers can be taken. If I take this answer, then both activities are carried out in parallel. This gateway waits for the second activity to be completed. When I get on this ship order, I can ship the order, or it can get interrupted if I don't meet my SLA. So if I interrupt it, then I end up in the end state shipment outside of SLA. So this is what I meant by process animation, where we're not doing numerical analysis of the process, but we're walking through the behavior of the process to make sure that we have the right behavior. Now, another aspect that is important is as you get into actual simulation or numerical simulation, then you have to be aware of the notion of randomness and likelihood. So let me switch again to my tool here. Let me go get that simple example. So now, very similarly, if I do the animation, you can see that at the top I have a parallel path. So that means that both activities will need to be done. And at the bottom I have an exclusive choice. That means that one of the two only need to be done. So this is in terms of the behavior of the model. I may want to fall into the simulation. So when I move into numerical simulation, and I'll run a pre-configured simulation here. And so the pre-configured simulation ran 10,000 instances of my simulation. So 10,000 instance was run, so this activity was done 10,000 times. I have a parallel path. 10,000 went here, and 10,000 went here. Now this simulation configuration was that my exclusive choice was as likely as one another. So by as likely, I should get a 50-50. But when I see here, 10,000 instances were run, and here I get 4,997, and here I get 5,003. So we see here that I'm not exactly at a 50-50%. So this is the notion of the coin toss again that I was talking about. Although this is 50% chance of either one being selected. Depending on the number of instances that you run, to get statistical significance, you have to run many different instances. So this is something to be aware and knowledgeable when you're doing simulation. So let me carry on with my presentation here. So the BPSim approach was to look at the capability of parameterizing every single aspect of the process from different perspectives. So the perspective that BPSim address is the temporal perspective, the control perspective, the resource perspective, the cost perspective, and the property and priority perspective. So these are all different perspectives that we can parameterize using BPSim standard, and either parameterize only one perspective and focus on that experimentation, or we can parameterize all perspective and look at different type of experimentation. So in BPSim, we have the notion of a scenario. A scenario is basically a collection of element parameters. So it's a particular parameterization of your model that you can use to do your analysis, simulation, and optimization. And you can have different scenarios defined for one single model. And these scenarios can be defined either from different randomness or using historical data. Now, what's particular in BPSim is that we can parameterize not only the process model as a whole, but we can go down and parameterize each particular element, the start event, the sequence flow, the gateways, the activities, with time parameters, control parameters, cost, resource, instance, and priority parameters. So you can do different level of analysis. There's a progression into those kind of level of analysis. So at the core level, you can do process validation, make sure you don't have any deadlocks, infinite loop, etc., or any logic fault. And that can be done, like I said earlier, through animation. You don't necessarily need full numerical simulation to do that. Then when you fall into time and throughput analysis, looking at processing and cycle time, or resource constraint analysis of your resource capability, the delays, the cost, and then finally the last level, using calendars, where you look at your resource availability against particular calendar period. So you can say, for example, this particular person works from 8 to 4, this other person works from 7 to 9, and then I have all these different parameters change your simulation. So going back to my input scenario for this particular example here, you can see that I can parameterize here. I'm parameterizing my scenario, and these are the detail of BPSim. I'll go and show you without the BPSim in an interface. So if I go into my example here and open this example of my order fulfillment, and I open my editor, so I can see that I have one scenario here, which is my BPSim scenario, and it's running here for 4 days, and my base time unit is in minutes. So I have a scenario, and then I can start exploring within that scenario how my different activities are configured. So if I look at all my activities here, you can see that for all my activities, I've only parameterized my processing time. My first activity's got a time of 5 minutes. My second activity is using a uniform distribution with a minimum of 3 and a maximum of 5 minutes. My third activity here is using a triangular distribution for a pattern of timing of the processing time with a minimum of 5 minutes, maximum of 10. And here I have a Poisson distribution with a mean of 12. So this is how I've actually parameterized my activities, and I have my different, so here if I go to my start event, I've parameterized this start event to be an intertrigger time of every 10 hours. So as you parameterize your model, BPSim will transform this into a file format that is augmenting the BPMN file, and we'll make it interchangeable. So if I run this simulation here, you can see that in this 4-day simulation, one time I finished with the no stock, and I finished 9 times with my shipment within SLA, and 0 time within my shipment outside of SLA. Now I have a warning here from the simulator that's telling me that I haven't parameterized this particular event here, and that's why everything is going true here. So, and here if I look at my activity ship order, you can see that my average processing time is 9.89 minutes with a minimum time of 5 minutes and a maximum time of 12 minutes. So I may want to go and change this model and come in here and go and edit this particular intertrigger time and give it a maximum of 12 minutes. So now, I've put 12 hours, excuse me. Let me delete this, make sure I include 12 minutes. So I put 12 minutes. So now I have that this will break at 12 minutes. So if I resimulate this, now you see that I have 1 here, I have 6 times here, and I went 3 times here. So that means that in my running, and then you can tell that now ship order was always blocked at 12 minutes because every time I didn't meet my SLA of 12 minutes, I used this alternative path and took me here. So now my maximum is 12 minutes, so I make sure that I respect my SLA, and my minimum is 5, and my processing time is still 9:44 as my average processing time. So as you're working with your model, you can experiment and create different experimentation like this in what you're doing. So a couple of points about this is to examine your output results as I did. So I saw that I didn't have any output going to that other end state of over my SLA. This was unexpected to me, so I checked at it. The simulator helped me in telling me that I didn't parameterize my exception there for my SLA, and I found an explanation. It would have been tougher if it was something that I couldn't explain, and that's when you have a problem in simulation. So what I had was more base level for experimentation in my simulation. So some business process simulation best practice to complete. Make sure you use the right model for the right goal. Align your objectives of your simulation with your model of the process. Make sure you're looking for the right answer to the right question. That is, make sure that you instrument your model correctly. So if you're interested about temporal aspect, make sure you instrument your model with all temporal perspective on all the elements. The right expert for the right task, make sure you use the right expertise for the right kind of experimentation, depending you're a novice or an expert in process or in simulation. Some of the caveats of business process simulation. A lot of time there's unrealistic user expectation. People think that process simulation is just a simple press button. It is the case when you're doing animation, but when you're doing more randomness and analysis of randomness in process model, it requires a certain level of expertise. Another caveat is that a business process model is not necessarily a simulation model. It depends on the goal. They may be misaligned, so your process model may not align with your simulation goal. And you got to be very mindful of misleading results, so garbage in, garbage out. If you get some very uncharacteristic results, you should look and make sure that you validate your as-is situation, and also be mindful of sub-optimization as a potential challenge. So that was my global look at process simulation, a quick introduction to BPSim. And I guess, Dan, we can open the floor to a few questions if we have time.
That sounds great. Thank you, Denis. Laura, do we have any questions? And if we do, could you read them?
Yes, we have one at the moment. What other business disciplines besides operations will simulation not be useful for training?
That simulation would not be useful. I mean, it depends on the type of simulation you're doing. So, for example, I would suggest that animation is useful for every aspect of the business. It's a very good way using animation to make people understand the behavior of the process and how responsibility change hands as you're walking through the process. I will also put that a role-play simulation is also very useful for onboarding of clients, of onboarding of employees. Numerical analysis becomes questionable for training because it is there mostly to get out some capacity analysis. So unless you want to train people to have a visualization of when, for example, a certain SLA is reached like I did. So hopefully I've answered your question.
We have a second one. What BPMN modeler software were you using to do the animation?
I was doing this animation and this simulation using the Trizatech BPMN web modeler. So this Trizatech BPMN modeler has both process animation and process simulation as per the BPSim standard.
Okay, I don't have any more at the moment.
Okay, well, thank you very much, Dan, for the invitation to talk to you about business process simulation and BPSim in particular.
And thank you, Denis. I think that this has been very helpful. As for those in the audience, one of the things that I think you're going to see more and more is the use of simulation when it comes to both continuous improvement as well as in process transformation or just business operation transformation. It's one of the things that we find is going to be very helpful in helping you reduce the cycle time going through your iterative designs. Because without simulation, one of the problems that you have is that as you move from design to design, what you're really doing is going from guess to guess as to what would improve that design. Through the techniques that Denis has gone through today, you can start to see how this can be useful in helping you focus from iteration to iteration in that design process. And then once that is in place and you now have a solution that's out there, we all know that whether it's regulatory requirement, compliance issues, market opportunity, whatever the driver is, you're going to have opportunities to continuously look at how that business needs to change. And as you start to do that, and you start to then have to justify those changes to executive management, these simulation tools take it out of the realm of, I think that will work better, to numerically and visually also showing why it will work better and what better really starts to mean. So this, I think, is an extremely important topic, and it's certainly one that we may, as a group, wind up revisiting because of that importance as this continues to evolve. So again, thank you, Denis. And if there are no other questions, Lara, I'll close the session today.
I believe that is all we have at the moment.
Okay. As I mentioned, the session will be put on the ABPMP website. So anyone who is a member of ABPMP, please go on out there and look at it, share it with your colleagues. And we're now developing a fairly rich set of different training webinars that are out there, so please feel free to use them. It's a benefit of the association. And with that, I'd like to one more comment, and that's Every month, the third Wednesday of every month at 2 o'clock Central Time, we have one of these training webinars. They are open to members and non-members alike. So please tell colleagues, friends about them, urge them to join in the webinars. And with that, and that plug for the association, I will thank you all for joining us today and close the session.
Thank you all.